Right, so over here at the bottom part, okay, please write down this summary. We're gonna put all the formulas together and then tell you how you can memorize these one, okay? Just like trigonometry, you need to use it, memorize it, so when you need it, okay, you can get it right away from your memory, right? So the first one, a to the x, will be a to the x ln a, right? And then log a to the x will be 1 over x and then ln a. So this is the way I remember it, so I don't forget it so easily. Let's look at the other two, right? E to the x, right? Prime, it'll stay the same, right? This one is a very interesting one, right? Always the same. And then you have ln x prime will be 1 over x, which we use the definition, the h approaching 0. Spend a lot of time proving it. Okay, once you write these four formulas down, can you raise your hand? Please raise your hand if you finish copying the four formulas. Nicole, yeah, okay, good. So as you can see from here, actually there are only two formulas needed, okay? If you can see the pattern here. So I just call this part as number one. This is the exponential one. Number two is the log one, okay? So if you think about the left-hand side, if I replace A as E, right? Over here, instead of writing A, I write E. Then it will become the right-hand side, right? You will get e to the x prime equals to e to the x ln e. But then ln e will be 1. So that's why it disappeared. Okay, so it's included. Okay, right-hand side is inside the left-hand side. Same thing with number 2. Okay, if I replace e as a, then it will become 1 over x ln e. And ln e again, it becomes 1. So you're just left with 1 over x. Okay? So in fact, you just remember, the way I do is I remember the right-hand side because it's shorter, right? So you have e to the x prime is e to the x. So a to the x will also get you a to the x, right? You see this, the look is the same, right? Ln x prime is 1 over x. So log x prime will also be 1 over x. You see where I highlighted, right? And the part that's not highlighted is just ln a. You just add an extra ln a beside it. And that's all, okay? So I just remember the right-hand side, the simple version. Then I can use it to remember the more general, okay, with the a. All right, so just little trick, right? Sometimes you can analyze all the formula and find a way, or create your own way to remember, okay? As long as you can remember it. Okay, so that's all the things that I want to cover in book 1. And we are moving on to book 2, okay? So you guys, please take out your book 2 now. Book 2, over here. Okay, we won't be doing too much. Apparently, we don't have much time left, but then we can take a look, go over the easy stuff. So next week, we can start on the more difficult things, okay? So the book 2, if you have it in front of you, can you raise your hand? Okay, and then we are starting with page 9. Okay, in book 2, there are 2 more applications which are less important or less difficult, okay, compared to other ones. All right, so usually they don't assign too much question on those 2. Okay, so let's look at page 9. So in book 1, the main focus was on equation of tangent, right? Prime it, you get the slope of tangent. And then we use that to apply to many type of questions. Basically, mostly about rates, right? The velocity and stuff. Now in book 2, the other big branch of the calculus is called sigma. And sigma has to do with adding, right? So adding things together. So that's why later on you will see we will be finding instead of equation of tangent, it has to do with area. So eventually, right, by the end of the course, you will learn how to do something like this. If you get a graph, right, like that, you'll be able to find the area of this if you know two functions, okay? And the idea is to add up a lot of rectangles together, right? Adding, so it has to do with sigma. And rectangle, because you know how to find area of rectangle easily, okay? So adding a lot of them. And then later on, you'll be able to figure out the volume of a 3D object other than cube, right? So maybe something like this shape. Okay, like a vase, right? You will be able to find the volume of this one. And the idea is to add up a lot of layers of circles. Okay? So that's give you a preview of what's going to happen later. Okay, and that's our our ultimate goal, right? Try to solve this kind of problem, and that's how they can be applied. Okay, so since it's got to do with adding a lot of adding up, we need to know something called sigma notation. So this is okay. This just basically summarize what I just said, right? The concept of integration. So instead of differentiation, we have integration. This is the main word in book 2. It's about summing a series of values, right? So adding up. For example, surface area of any 2D shape is sum of tiny squares. A lot of little squares or rectangle added up will give you an area. And then the volume is the sum of many cubes. Okay, so this idea can be traced as far back as ancient Egypt. However, it was only until the first half of 19th century the calculus was given a more suitable foundation. So they put it into symbols, right, and then find different methods. So in this section, we'll start by learning how to evaluate sums with many terms using the Greek letter sigma, okay, which corresponds to our letter S. Right? So here is a lot of sigma notation. So given a sequence, right? Sequence means a list of numbers. If we connect all of them together with the addition sign, then we call that a series. Okay? So without adding, right? Without adding together, it's just sequence. Adding together is called series. And then we need to know some notation here, right? So this part is called the general term. Okay, and then so AI is like a formula. Okay, so for example, the example down here, this is called the AI. Okay, so AI is I squared. So it's a formula for finding different terms, right? And I can change. I will change from M. So the M is the starting number, okay, for I. Starting number for I. And then on the top is the ending number for I. So I will start, for example, question A, I will start at 1 and finish at 3. Okay, so you just go in order, okay, one by one, 1, 2, 3, right? So we know I will change from 1 to 3, right? And then each one you plug it into the general term. So I'll demonstrate the first one, okay? So I starts from 1, I plug it into the general term, you get 1 squared, right? Because I squared. Second term will be 2, right? So 2 squared. and then finish when I becomes 3. So 3 squared. And because of sigma, it tells us to add them all up. Okay, so this part, writing out this way, is called expanded form. Any questions so far? Okay, so we just learned the expanded form, and this form is called a sigma form. Okay, write it out in sigma. All right, so I would like you to try the following questions, okay? So let me know when you finish all of them, when you tried all of them, okay? If you don't know how to write it, you can just leave it. Just do the ones that you know, and then you can raise your hand, okay? And we'll quickly go over each one of them. You don't need to calculate the answer, okay? Just write out the expanded form. You don't need to add them up. So raise your hand if you finished. Okay, Jesse, can you tell me the question B?
Question B, I just got 5 plus 6.
Yeah, 5 plus.
Yeah.
Very good. Okay, Jeffy, how about C?
I got bracket negative 2 to the power of 0, and then plus all the way up until bracket negative 2
Okay.
to the power of 5.
Yeah, okay, that's a quick way to say. Okay, negative 2 to the 1, negative 2 to the 2, negative 2 to the 3, negative 2 to the 4. Okay, Joan, how about D?
I got 1 plus 1 over 1.
1 plus 1 over 1, so that can give us a 2.
2. And then, do you want me to just, okay, I'll just, 3 over 2.
Yeah.
Plus 4 over 3.
Yeah.
5 over 4.
Yeah, very good. Okay, so you can start to see the pattern. Okay, question E. E for Emily.
Can you let me do it?
Yep.
It would just be sine 1 and then sine 2 plus sine 3, and then does it just go on?
Until
N?
sine n, right?
Yeah.
Yeah, what's the term before sine n then? If the last one is sine n, what's the term before?
Whatever comes before it.
How do you express it if it
Infinity?
was
I don't know.
infinity? N is a number. So how do you get the number before? What would you do?
N minus 1?
Yes, okay. This is a very important concept too. Later on, we'll be using it, okay? So the term before, you just subtract 1. And even the term before, you subtract 2, right? Okay, how about F? Carrie, do you have F?
You can't sub anything, so would it just be 4?
4. What about next term?
4?
Also 4. How many 4 will there be?
4 4s.
Yes, okay, so this one, because you need to keep on counting the I, right? I equal to 1, give you a term. I equal to 2, give you another one. You have to finish until it becomes 4. So you can pretend, right? You can look at 4 as having and I as well, but it will be 4i to the 0. It's the same thing, right? So every time when you sub in a number for I, it just kind of disappears, right? But the terms still exist, okay? So you still get 4 terms. Okay, just a little thing on the side, okay? If I have sigma of, let's say I equal to 17 to 51, and then some formula, okay, general term. How many terms are there? How do we find out how many terms there are?
You take the top number, subtract the bottom number plus 1.
Okay, yeah, you need to subtract and then add a 1. Because if you don't subtract, if you don't add a 1, you are not including the I equals 17. Okay, think about question F. 4 minus 1 is 3, right? That gives you 1, 2, 3. But then you're not including the first one. Okay, so you need to add a 1 back. Okay, so if I have M, right, M and N, then number of terms will be N minus M. Remember, you need to add a 1. Okay, so you can put this on the side. Okay, just in case they ask how many terms there are. Okay, in total. Any questions here? Okay, we'll move on. Okay, this is pretty easy. Now let's take a look at what we have here. We have some properties, okay, for dealing with sigma. So kind of try to relate this with derivative, okay? Some of the property is similar to derivative. Remember when you do the prime, right? If the function, okay, let me rewrite this. If I want to prime something, right, a function that has a constant in front, let's say 5, right? I want to prime this one. The rule was the 5 will just stay there. I could just prime the function. It won't change. Remember this one, right? We have something similar with sigma as well, okay? So AI is kind of like a function, and then C is a constant. So I want to do sigma of a constant times a function, right? The constant can go out, just like the 5 will go out, okay? It won't be affected by the sigma, okay? We'll try this out with an example to show that it really works, okay? So on the right side, please write out the expanded form, okay? For number 1, you have 2 of them. One of them has a 5 inside, 5 is the constant. The other one is having the 5 outside, okay? So write out the expanded. This one only has 2 terms. Okay, so please write it out and raise your hand, okay, for both of them.
Wait, sir?
Yep,
Wait, so the first one you don't want us to put it in the front, or you do?
you don't.
Oh, okay.
Yeah, the second one is keep it at the front and then write out the expanded form for the
Okay,
second.
thank you.
So what I want to show here is to show that they should equal each other, right? The answer should equal. Even though the way you expand is different. Okay, so for example, first one, it will look like 5, 1 squared, 5, 2 squared, right? 5 times 2 squared. The second one is having a 5 in front. And then do the sigma of I squared, okay? How do we expand the I squared? Joan?
Wait, expand the ice. Oh, just 1 squared plus 2 squared.
Yeah. Okay, so having a 5 inside after and having the 5 in front is different, but then their answer is equal, okay? Because you can see that the 5 can distribute, right? It will be the same, all right? Now for the next property is saying that add and subtract, I can split the sigma. Same thing with prime, right? If you remember, if I have f plus g prime, I can prime the first one and prime the second one, right? You see there's a connection here, right? So same thing here. The first one is without splitting. Second one is split, okay? So please write out the expanded form again and raise your hand. Okay, let's check the expansion. Jeffy, what do you have for the first one?
I have bracket 1 plus 1 squared plus
Mhm.
bracket 2 plus 2 squared.
Yep. Okay, Leon, how do you expand the second one?
I'm not sure if I did it right, but I got 1 plus 2 and then 1 squared plus 2 squared.
Yep. So as you can see from the expansion, right, it's the same result, right? It's just in different order. They are all adding, okay? So final answer should be the same. So if it's subtraction, it should also be the same, okay? The next one is the one that's not equal, okay? So make sure you highlight that, right? It's not equal to each other. For anything that's multiply or divide, you cannot sigma each one separately, okay? So please expand the right hand side, and then this time, because they're different, I would like you to evaluate, okay? Help me find the answer at the end. Add them up, okay? Find out what they are. First, write out the expansion and then calculate their answer, okay? Only 2 terms. Okay, Jesse, how do you, what's your first answer? Final
I
answer.
got, oh, sorry, just the answer?
Yeah, just the final answer.
I got 9 for the first one.
9 for first one, okay.
Yes, sir.
And Carrie, what about second one? Do you have answer?
I think it's 6.
6. Anyone disagree that got different things?
I got
Yeah.
15, but I'm not sure if I'm right.
15 for which one?
Second one.
Second one, 15. Anyone else? Joan, what do you have?
I got 15.
15. Okay, let's check. Okay, we'll check the expansion. So for the first one, we'll be starting with 1. So 1 squared, right? Plus 2 squared. So that will be like 8 here plus 1 there. So that's a 9. That's good. Okay. Second expansion is you do the first sigma, multiply with the second sigma, right? So be 1 plus 2, 1 squared plus 2 squared. So this is 3, that is 5, okay? So that makes it a 15, okay? All right, so I think we can stop here for now, all right? And then next we will learn the formula, okay, for the sigma. And later I'll post the homework, okay? If you have questions, you can stay after class. All right, see you everybody.
Thank you, sir.
Thank you.
Thank
Bye.
you, Jason.
Goodbye. Bye.